In this video tutorial, we'll be doing the full design of the Daridon cell trap chip. First, we place the ports by selecting the port placement tool from the toolbar. We then adjust the values of the port and then generate an array of these things in the vertical direction. We then create a pump, which is part of our design. And we place the pumps on the canvas. And we replicate the same thing by using the generate array tool once again. Because it's a demonstration, I already calculated what the distances between the placements would be. In practice, you might want to play around with this a little more. So then we can create a connection using the connection tool, where we actually connect the pumps and the ports. By just left clicking on the port, we start the connection, and we terminate the connection by left clicking on the pump. We can also place waypoints on the way, as we can see right now, by just left clicking it on the canvas. I'm panning down with the down arrow button. Now that the ports have been completed, I reset the view by pressing the F key, and I'm going to create another one more port which is required for this final pump, and set the radius, and then create the connection between the pump and the port. As you can see, I created multiple waypoints by left clicking as I went along. So I'm going to create the rest of the connections which are necessary in the device. For these connections, I'm just making an approximately similar connection network as seen in the original paper. Obviously, future versions of 3DOF will have better tools for calculating the resistances and the delays in the fluid flow. But for now, this version, we will just have simple placement of these connections. So now that we need to have a single cell trap, it's a custom cell trap which is not part of our standard library. So I created a DXF design of this cell trap using Fusion 360. So I import the DXF into 3DOF using the import functionality, and I call it a single trap. And as soon as I do that, as you can see, the single trap popped up underneath the imported category. So, and I select the single cell trap and place a new single cell trap on the canvas. Now, to finish up the flow layer of the design, I will add the chambers and the necessary ports around it. Because I want to place it exactly coincidental with the single cell trap, I modify the grid dimensions so that I can actually place it over there. Otherwise, a snapping grid will try to ensure that I don't place it outside of the grid. Now that I've placed it, I'm going to create the other chamber setting by setting the width and length values. And modifying the height to 100 microns. Then I complete the flow layer design by creating all the connections and the pumps. One of the user features which I did not talk about earlier was that when using the connection tool, if you hold down the Alt key, it'll make sure that it creates the connections in a straight line. So even if you go a little sideways, it'll always try to snap and go 90 degrees. So I moved the component closer by hitting the move tool. Then I copy the port component so I can generate another port with the same properties. Now that I finished the flow layer, I switch on to the control layer, where I will create the ports and connect all the pumps and create valves for the rest for this device. So first, I'm going to create the ports required for the pumps. I place them nicely, evenly spaced. Now I'm going to make all the connections between the valves and the ports. But because I made all the channels too wide, you can't really make out the difference between the valves and the channels. So I'm going to now modify all the widths of these channels. And as you can see, it's pretty easy. I just need to select the channel, select the connection, and change the width and change the channel width of these connections. I believe in future versions of 3DOF we will add a better way to do this more automatically, but for now the user has to select each individual connection and modify the channel widths. So this time, before making the other pump connections, I preemptively made all the changes. Now I'm going to place the valves. So by using the valve tool, I don't really have to do much other than just make sure I'm on placing the valve on a connection. By placing a valve on a connection, the valve tool will automatically orient and readjust the valve to ensure that it is on the connection. In cases of valve 3D, as you can see on the left toolbar, it will also redraw the connection so as to account for the break using the particular valves which we use over there. So once again, I need to adjust the grid a little so that I can actually place the component correctly. Now that I'm done placing the valves, I'm going to make the corresponding ports by once again copying and pasting Control C and Control V, pasting. So that'll allow me to place ports of similar properties. Once again, I need to change the values of the channel widths. So now I'm going to change the value once again to 300 and start making the rest of the connections between the valves and the ports. And that concludes the design of the Daridon cell trap. Now we can anytime save the device design by clicking Ctrl S, and because we wanted to save it as Daridon celltrap.json, we rename the device by going to Edit Device tool, by clicking on the Edit Device button, and now the new JSON file has Daridon celltrap as the name of the JSON. We can also save files required for CNC milling this device by clicking on the CNC button over here. That will download a zip file which contains all the SVGs required for the design.